Okay, so equations have an equal sign, expressions have no equal sign. Try an equation, you identify the unknown for what you're looking for, and assign a variable to it. So for instance here, in 62, Ruby assigned a variable C to cashews, A to almonds. That was wonderful, right? She picked A, cool, it stands for almonds, that's rad. And look for keywords to replace the equal signs. Is, as much as, is identical to, is the same as, equals, those all mean. Now we're going to the other side of the equal sign. All right, example, Daytona 500 is widely considered to be the most important event of the NASCAR circuit. The distance around the track is 2.5 miles, and the race is a total of 500 miles. Look below to see how you can write an equation to determine how many laps it takes to finish the race. The length of each lap times the number of laps is the length of the race. So we're going to let L represent the number of laps. So 2.5 is the length of each lap. L is the number of laps it takes. And so together, we can figure out how long it takes, how many laps it takes to finish the race. So 2.5 L equals 500. So if I divide by 2.5 on both sides, I see it takes 200 laps for the Daytona 500. All right, example 1, translate each sentence into an equation. A number B is divided by 3. A number B divided by 3 is identical to 6 less than C. So what this looks like is B divided by 3 is equals 6 less than C. So 6 is less than C. So it's a minus 6, C minus 6. Okay. 15 more than, so that means add Z times 6, so Z is multiplied by 6, so 15 plus 6Z, so 6 times Z is 6Z.
Could it be like 6Z plus 15?
Yeah, that's fine. Commutative property of addition. Here, they just said like 15 more than, so I just was going along with what the word said. Is 11 less than the product? So the whole less than means it goes on this end, it means minus 11. The product of y and 2, so that's 2 times y minus 11.
Why can't it be 11 minus 2?
Because it's 11 less than. So it has to be, we're subtracting 11. 11 less than this. Cool?
Is equal.
Yeah. Is means equal. No. No, we're just translating the sentence into an equation. We're just practicing. It's kind of like rapid fire, getting ready for like word problems, helping you guys build this vocabulary. Twice the difference of a number and 3 is the same as means equal. The sum of a number and 7. Okay, the sum of a number and 7. So sum of a number plus 7. So it's m plus 7. But on the left side, twice the difference of twice, so it's 2 times. Difference of means subtraction, so a number and 3. So it's going to be 2 times m minus 3. The difference of a number and 3 is m minus 3. And if I want twice that, I put 2 on the outside. Okay, so translating sentences to algebraic expressions and equations is a very valuable skill in solving real-world problems. If you're given an equation, you can write a sentence or create your own word problem. So here we're given this issue that's going on. We could write our own word problem. We could write an equation for it to solve. So a jelly bean manufacturer produces 1,250,000 jelly beans per hour. How long does it take to produce 10 million jelly beans? Okay, so per hour means multiply. So what I want to do is I'm going to take 1,250,000 times x, because x is the number of hours. And I want to solve for x. How many hours does it take in order to reach 10 million jelly beans? So I'm going to have to divide. So divide both sides by 1,250,000. So that goes away. I'm left with x is equal to 8. So this stands for 8 hours. So it takes them 8 hours to make 10 million jelly beans. So this is a lot of zeros, right? But if I divide by 10, you can cross out zeros this way. So if it's a little easier, you could put 1,000 divided by 125 into your calculator, or you could put 10 million divided by 1,250,000. Awesome. And if I'm ever like going too fast or I scrolled and you need more time to write, just like let me know. This is a good place. Dylan Bookbinder. Woo! Good morning.
Our word count is this.
No, not on the quiz. Yeah.
Because it's 1 through 3.
Because it's 1 through 3.
Well,
It is.
Quiz is 1 3.
It's 1 through 3. This is section 3.
No, I know, but you just said it's not going to be
A word problem. It won't be a word problem on there.
What else is going to be there?
Well, we have the rest of the notes for 1.3 to do. But so this part with like building your vocab and how to write equations, like I'm not going to put one question on it to fully like test you, right? Because the rest of the year, like I'm gonna have word problems and you're gonna have to know how to do it. So, okay. So a rule for the relationship between certain quantities is called a formula. So if you guys are in physics or chemistry, you have formulas, right? The formula to figure out height of a soccer ball kicked. The chemical equations are all formulas, right? They represent numbers and give form to general rules. So one example is the perimeter of a square equals 4 times the length of a side. So perimeter, we know, is P, and it equals 4 times the length, so 4L. Equals means equals. So translate into a formula, so P equals 4L. Smiles. 4 times L. So that's the formula. Literally, every time I want to find perimeter of a square, I can just use this and plug it in. It's general enough, I can use it forever. If the length of the side of a square is 10 feet, use the formula you wrote to find the perimeter of the square. So it says L is 10. So if I want to plug in, I can say P equals 4 times my length, which is 10, so that says 40 feet. This says 10 feet. So just plug in. So we know how to substitute in.
Equals 4 times.
Yeah, because right up here, it says the perimeter of a square equals 4 times the length of a side. So perimeter P equals, equal sign, 4 times length, 4L.
Oh, so it's not like always a formula.
This is always the formula for a square.
Oh.
But normally for perimeter, you say length times width, but in a square, the length is equal to width. I'm sorry, perimeter, that's area. Perimeter is 2 times length plus width. And if your length and width are the same thing, this is going to be 2 times, if length is equal to width, in a square, which it is, right? Each side in a square is the same. I could say this is equal to 2L, 2 times my length. Well, 2 times 2 gives 4L. So like this is the general perimeter for a 4-sided object, for a rectangular square. But if I only talk about perimeter of a square, well, since I know all the sides are equal, I know it's going to be 4L. Okay. So, properties of equality used to solve equations. In an equation, the variable representing the number that satisfies the equation. To solve an equation means to find the values of the variable that make it true. So, addition, property of equalities. So, more or less, this is like a solid review of Algebra 1. 1-step equations, 2-step equations. Why can I do this? Over and over again. Addition, property of equality. If an equation is true and the same number is added to each side, then the resulting equation is also true. So, if A equals B, then I can say A plus C is equal to B plus C, meaning if I add it to one side, I can add it to the other. So where this comes into play, if I add 3 on both sides, like this is why. The addition property of equality is why I can do my 1-step. Add 3 to both sides and I have X solved. And then if I want to go through, I can check So x minus 3 equals 5. So if I put in 8 in for x, I get 5 equals 5, and that's true. So that's what I mean when I say check. So this is confidence booster time where you're like, heck yeah, I got this, I know this, look at you go. We're going to do example 1 now. So x minus 5 equals negative 10. I'm just going to go down the row. Talia, what should I do to solve for x? Add 5 to both sides. And what's x equal to? Negative 5. Okay, it says check your solution. And I believe this is a simple enough problem. One step, we're fine. Shouldn't have put that. Sometimes I'm lazy. Okay. B, let's go to Dylan Benson. How should I solve this one?
You add 8.
Add 8. What's R equal to? 40. Beautiful. Subtraction property of equality? It's the same thing. If I have A minus C, it's the same thing as B minus C. If A equals B, as long as I do to one side what I do to the other, we're good. So for the example, if I want to get x by itself, as long as I subtract 5 on both sides, I'll be good. So equals 6. And of course, if you were going to check it, I'm just going to check the one example to show you. So I have 6 plus 5 equals 11. Well, 11 equals 11. It works out. Beautiful. So we can go ahead and we can try these next ones. Dylan Bookbinder, let's do 2A. Exactly. Subtract 0.6 on both sides. We get y equals 2. And Eli, what about this next one?
Subtract 47.
Oh, subtract 42?
I mean 42.
Yeah.
16. Yeah, -2.
Wonderful. Okay, so we're confident. We're confident we can do this. You know how to do one-step equations. Golden. Almost done. Multiplication property of equality. So if I say A is equal to B, I can go through and say, hey, let me multiply each side by a certain number, and now that same equation's true. So if x over 2 is equal to 10, I can multiply both sides by 2. The 2's cancel out, and I'm left with 20. So this is just justifying when you have an equation, if you can add a number to both sides, you can subtract a number from both sides, you can multiply both sides, you can divide both sides. When you have an equation, what you do to one side, you have to do to the other. So over here, if I have 3/4 x equals 12, Lauren, how would I get rid of this 3/4?
Will you find it with the full third?
I want to get rid of the 3/4.
Okay, so don't just divide by 3/4 on both sides.
Yeah, I could, and it's the same thing as if I wanted to multiply by the reciprocal 4/3. So if I take 4/3 and multiply by 3, I take 3/4 x, multiply by 4/3, take 12, multiply by 4/3, the 4's cancel out, the 3's cancel out, and I'm left with, let's see, 4 times 12 is 48, divide by 3, it's going to be 16. So you could multiply both sides by 4 and then divide by 3, but instead of doing 2 steps, you could multiply by the reciprocal.
Wait, I did take class multiplication, take 36 over 4.
30,
Like 12 over 1, like it's 4 over 3, it's
4 over 3.
Yeah, it's 12 over 1.
Oh, yeah.
And then I got
Right here. 48 over 3.
36.
Oh, you can't do cross multiplication. That's only if there's an equal sign here. You only can do it if there's an equal sign. With these fractions, you have to multiply across. Yeah.
And you don't have to.
No, not when you multiply. If you're adding or subtracting, common denominator. If you're multiplying, you just multiply across. Cool. Division, property of equality. If an equation's true, blah, blah, blah. Literally the thing is, if you divide the left side by a number, you have to do the right side of the equal sign as well. So if I take A and I'm dividing by C, I have to do the same thing over on the right side. So if I want to solve for x here, if I'm dividing the left side by 3, I also have to divide the right side by 3. What you do to one side of an equation, you have to do to the other. All right, 42 divided by 3 is 14. Yeah. Cool. All right. Let's check these. What did I leave off on? Lauren. So A, how would I go about this one?
Divide by 2.
So W is being divided by 2.
That's about 18.
I want to get rid of the, yeah, if I multiply both sides by 2, it'll go away. So 2 times 18 is 36, is W. Ruby, B, how would I go about this one? Equals, what is it? 28? Cool. Yeah, 28 equals B. So what you do to one side, you have to do to the other. Okay. Hold on, let me see how much more. Okay. So multi-step equations. So this talks about the Tour de France, blah, blah, blah. You can read it. But multi-step equations, you have to undo each operation by working backwards. So if I'm wanting to solve for k, I have to get rid of everything that was being added or subtracted to it. So if you're trying to get a variable by itself, you have to work up and work backwards. So first, I subtract 20 from both sides. So I have 4k equals 216, and then I can divide by 4 on both sides. So I see k is equal to 54. And here, I think this is describing the shortest portion of the race, kilometers. Cool. So we'll try a couple of these. Let's start with, let's go through the left side and just do these. So, sorry, what? It is. Yep. It is. Yep. There's a simplification problem and a solving problem. So, all right. So I'm going to do A first. You have to get rid of the term that doesn't have the variable in it. 2a equals 10, and then I can go through and divide by 2 on both sides. So you have to work backwards. The first thing you have to do first, you have to subtract 21 first, and then you have t over 8 equals negative 7. And then we have to do the opposite operation. Right here, t is being divided by 8. So to get rid of it, we have to do the opposite. Instead of dividing, we're going to multiply both sides by 8. So I see t is negative 56. Yeah. Let's do E. Who? Are you okay?
Yeah.
Okay. I just don't see you writing for a while. Let's see. Ruby, you did the last one, right? Jesse, do you want to do this one?
Sure.
E. Here we go.
Okay, so
What's the first thing I should do?
add 1 to both sides.
Maybe, but you see how n minus 1 is being divided by negative 3?
Don't multiply them.
Yeah, so since instead of dividing by negative 3, we want to do the inverse, which is multiply. Multiply each side by negative 3. So I have n minus 1 equals negative 30, and now I do what, Jesse? Exactly. So n equals negative 29. Cool. Let's do example 1. A down here. 4w plus 6 equals 7w. So now there's variables on both sides. So I need to get it so all the variables are on one side, and then it's by itself. So let's see, Isabella, what's the next thing you do?
So you subtract 4w.
Mm-hmm. Exactly. So you have to get all the variables, like variables, together, and then on one side, numbers on the other, and then you can solve. This did not write properly. This did not print properly. What is this supposed to be? See, what's this supposed to look like? 7 and okay. Let's do B. B is a good one. So how would I do B? Is it Elizabeth? Sorry. So move all the variables on one side, numbers on the other.
Yeah.
Little hint. And so I have S over 2, and I want to subtract 1/4 S on both sides. So I'm going to subtract 1/4 S on both sides. I should probably write it below. Okay, subtract 1/4 S on both sides. So the question is S minus 2 minus S over 4. Because 1/4 S is the same thing as S over 4. How would I make it? I need to have common denominators. So how do I do this, Elizabeth? Huh? All right, what's the common denominator here? 4. Yeah, 4 would work. And to convert this top one into a bottom of 4, you can multiply the top and bottom by 2. So this is like a clever form of 1. I'm using the multiplicative and identity. So multiplying by 1, because 2 over 2 is the same thing as multiplying by 1. And when you multiply anything by 1, it's itself. So I have 2s over 4 minus s over 4, what? Is it making a little more sense? Because the fractions?
No, I'm usually like
Or-
fractions, it's just that when it's with the S in it.
Huh? It doesn't look organized?
What's the problem with it?
Yeah, it's not nice looking. Maybe I'll rewrite this portion. So, subtract 1 from both sides. I have s over 2 equals 1/4 s minus 7, and then I subtract 1/4 s on both sides. And so this portion right here, this calculation, that's what I'm doing right here. I'm figuring it out right there. Huh?
So how on earth are you supposed to get, like, so it's S over 2 minus 1/4 S?
Right, 1/4 s is the same thing as s over 4. 1/4 s, same thing as s over 4. Because if you take, hold on, if you take 1/4 times s, literally it's s over 1, you get s over 4. It's the same thing. Okay, so I have s over 4 minus, s over 2 minus s over 4. I need to have a common denominator. Alright, so Elizabeth said denominator is 4. I need to change the left fraction into a bottom of 4. So I multiply the top by 2 and multiply the bottom of 2. That way, I get to this line where I actually can do the subtraction. So 2 times s is 2s. 2 times 2 is 4. So I have 2s over 4 minus s over 4. So it's 2 minus 1. 1. So I just have s over 4. Okay, so coming back, I have s over 4 equals negative 7. And the last thing I need to do is multiply by 4 on both sides. So I get s is equal to negative 28. So this is it's a little bit harder one because we got some fractions up in here. Yeah, so this one's definitely harder than D. C, once you distribute, it's much easier.
Do you need a problem like this?
B?
Yeah.
No, it'd be more of like a test question because you need more practice with the fractions. I'm not gonna lie, when I made the notes, I was throwing in fractions here and there because I'm just trying to gauge how you guys are with them. Okay, huh? Well, it is very diverse. So this section in particular is struggling with the fractions. So, yeah. So I'm gonna throw in more fraction questions for your calculator. All right, some variables have no solution, and some equations are true for all values of the variable. These, what? What's wrong? Yeah. You do have to. What? Yes, the hats. So, so many questions. Nope. Nope. It's on paper. That's what I did with summer school for a while. Yeah. No, it's on paper. You do have to have your calculator. If you forget your calculator, you can do the quiz without one. That's the dealio. You have to have yours. It has to be a TI Inspire because I'm going to put the hats on, and then you're going to. It blocks all your notes. So if you download any PDFs, it won't allow you to access them. Yeah, you can. It press to test blocks you from like certain functions in the calculator, but I allow you to have all access to the ones you need to do your quiz. It erases all the things, all your calculations that you did. That way, I mean, let's say, Eli misses, he's got pneumonia or whatever tomorrow, and cool. So, and it also allows me to see your screen at any time you're taking the quiz. So, cool. It just, it reduces the, like if you have any urge to like cheat or anything like that, it just like cuts it short because it's not going to happen. That's what it does. All right. Huh?
Are they new? Yeah.
Right. So I don't think in a rates class you use them, but in some of the other classes last year we did. Okay. Some equations have no solution. Some equations are true for all values of the variable. These equations are called identities. Example, no solution. So if I distribute this out, I get 2x minus 8 is equal to 2x plus 1. If I subtract 2x from both sides, I'm left with negative 8 is equal to 1. Like, no. This is not ever going to work, and this is why it's a no solution. So the way we write no solution is like that, no solution. And an example where, because it doesn't matter what value you plug in for x, it will never work. It's a no solution. Versus all real, so I distribute this out. Half of 6 is 3x. Half of 12 is 6 plus 1 plus 3x plus 7. So notice the left side is equal to the right side. If I subtract 3x on both sides, I get 7 equals 7. Well, that's always true. It doesn't matter what number you plug in for x. This is always going to be true. And so it's going to be a solution of all real numbers. So all real solutions. So the way we write it is like this with that special R. Special R. All real solutions. Didn't I give you the practice quiz?
Yeah.
Cool. Got it. Cool.
Sometimes teachers put stuff like small.
So if I have it on homework and it's in class and notes and it's more than just like one problem, it's like fair game. Yeah. I'm confident you can like solve these equations. I just want to talk about a couple of properties of equality. Reflexive, any term is equal to itself. We did cover this yesterday a little bit. Reflexive and symmetric. So symmetric, it like flips it. If x equals 7, 7 equals x. So both of those were in section 1.2. Transitive and substitution were also there. So this example 3 is a solid example of what I could put on your quiz. So instead of the number 8 on your quiz, this would be something I would put instead. Which property is illustrated? And I will give you the list of properties and you get to choose. But I'm going to give you all the properties, and honestly, you only need 3 or 4 of them. So then you have to know like which goes with which. All right, so if negative 11a plus 2 equals 3a, then negative 3a equals negative 11 plus 2. Which one is this? Well, reflexive, it's literally the exact same thing. Notice x squared plus 3y equals x squared plus 3y. Symmetric, because I'm flipping the left and right sides. Versus C, what is C? 12 equals 12. Reflexive. Reflexive, and then B, the last one, if x equals y and y equals z, then x equals z. Transitive.
Transgender.
Unnecessary. You don't need to comment. I'm trying to do some class. All right. So this is more what the problems would be like. Instead of number 8 on your test, it'll be maybe 4 questions like that. Okay. Example 5. The properties of equality are also useful when solving an equation in terms of a certain variable. There's no way to arrive at a value for b, but you could solve for b in terms of a, literally switching it around. So to get b by itself, how would I do that? Minus a. Okay, so we already did something like this. When it says note the property used in each step, it's okay. I changed my mind about doing that.
Oh my god, wait.
What I want to do is solve for b. How can I get b by itself? Minus 3a, so I have 3b equals 3a, now what? Divide by 3. So I get b equals a. Yep. There is a problem like this. We did this, let's see, the first day we did a couple of problems like this. So you'll notice that like these 3 lessons are kind of meshed together. Once again, properties. All right. Solve for h in the following formula for the area of a trapezoid. So I want to get h by itself. So what's the first thing I should do? I want to get h by itself. So right now, h is being multiplied by b1 and b2. Oh, okay, let's multiply by 2 on both sides. So that crosses that guy out. So I have 2a equals h times b1 plus b2. I still need to get h by itself.
I'll do all over b1 plus b2.
Exactly. I can divide by that whole quantity.
And then so 2a over b1 plus b2 equals b.
Exactly. So this is also like one of the problems on your practice quiz, which is what one of your problems on your actual test will be similar.
It's
Like getting one of the variables
that
like
one's
by itself.
it's
Yeah. It's kind of like the Celsius problem that we did. Okay. This one?
Could we like do
Yeah.
it similar to 7? Because I was having so much trouble with that one. Like on the practice quiz, I was
Cool. So I'd request to do this one again. I'm going to go over it again. So I have a equals 1/2 h b1 plus b2. I'll do it a little different this time. Instead, I'll first divide by this whole quantity right here. Divide both sides. So I have a over b1 plus b2 is equal to 1/2 h. So I also could write this as h over 2. And maybe it makes it a little easier to figure out how to do this. So I multiply by 2 on both sides, and then it will cross out, and I'll be left with 2a over b1 plus b2.
Do you prefer that we, if we get like an decimal answer, like for number 1, I got like 11.313708.
Does it say round to the nearest hundredth? Okay, so you should round to the nearest hundredth.
100th or?
It depends. If it says to the nearest tenth or hundredth, you follow what it says.
Okay.
Okay, and then I just want to show you this just for the last minute or two of class. So tomorrow you need your calculator. We'll start class by we're going to take the homework, staple it, put the hats on, and then do the quiz so you have as much time as possible. You'll notice your username is pretty much your first name. So Talia, your username is Talia. Dylan Benson, I'm sorry, there's two Dylans. Sorry. So Dylan B. Dylan, bookbinder, it's your first name. John is in the other class. Eli, Lauren, I have a different Ruby, so it's Ruby G. So I'll put this up tomorrow. I need to add you in there, which is your first name.
Oh, yeah.
So tomorrow, when you come to class, you'll have all 3 homework assignments done. Hold on. What are you doing? I'm literally talking right now. So when you come to class tomorrow, you're gonna have all 3 homework assignments done.
Yes.
I'll give you the homework cover sheet, we'll staple it together. We'll get the hats on your calculators. So honestly, this will take 5 minutes, and then we'll have most of the time for the quiz.
Yes, ma'am.
Cool. So let me know if you have questions. Have a good rest of your day.
It's like a red light. What does it mean?
It's charging. It was really low.